Good morning, everybody. I hope everybody's doing well. We're going to get into our unit on graphing exponentials and logarithmic functions. So we're going to start today on just graphing exponentials. So there are two types of exponential functions that we'll be graphing. There's exponential growth equations and exponential decay equations. So we need to know the difference between those, growth and decay. So the steps to graphing are going to be exactly the same, just your shape is going to be a little bit different. So here we got the general form for an exponential equation. So same kind of concepts. A is going to be in front. That's going to talk about a reflection. And also going to talk about a vertical shift. Up here we also got x minus h. That is still your horizontal shift. And then the plus k at the end, nothing changes. The plus k at the end, that is your vertical shift. So those are still in the same spots that we've been doing previously all semester. So growth and decay, how can we tell the difference? So we can tell if an exponential function is growth, or decay based off of this b value right here. So that b value here, that number that's getting raised to the power. So if b is greater than 1, we always have exponential growth. If b is in between 0 and 1, so it's that fraction, it's exponential decay. And then remember, if it's a negative out front, that's going to be a reflection. So we're looking at just that b value. So taking a look at these, are these growth or decay? So here I got the number 2. So b is 2, 2 is bigger than 1, so b is 2, 2 is bigger than 1, so that is growth. Here I got 1/2. So b is 1/2, that's the number getting raised. 1/2 is between 0 and 1, so that's decay. Here I'm just looking at that number here, so b is 1/5, so decay again. Here I got 4/3. 4/3 is bigger than 1, it's 1.33, so that is growth. So looking at that, all you're looking is that number that is getting raised to the exponent. So growth and decay, know the difference in that. Horizontal asymptotes. So to find the horizontal asymptote, you'll see that label as HA. We're always going to set y equal to the value of k. So here, nice and simple, here's your k value. It's a positive 3, so I have a horizontal asymptote at y equals 3. Horizontal asymptote, it's going to be y equals 1. It's an equation, so make sure we are always putting it as y equals. So here I got a minus 2, so my horizontal asymptote is going to be y equals negative 2. Horizontal asymptote at y equals negative 5. So on and so forth. Now, if I add another one in here really quick, if I say y is equal to 2 to the x plus 4, I'm not adding anything. So my horizontal asymptote is going to be y equals 0 here. So in a sense, I'm adding a 0 here, so my horizontal asymptote is going to still be 0. All right, so kind of some background information. So now let's look at graphing exponential functions. So when we graph exponential functions, we got a few steps. So we're always going to start by drawing the asymptote. Then we're going to determine two key coordinates. We're going to start with 0 and 1 for our x's just to make things simple. You can sketch the graph and the coordinate that's closer to the asymptote, and that will tell you which side of the graph approaches the horizontal asymptote. All right, so here we're going to graph y equals 2 to the x minus 1 plus 3. So some questions we're going to look at here. My parent function is just the basic, so it's just going to be y equals 2 to the x power. So since 2 is my base, it's a growth. I'm adding 3 to the end, so my horizontal asymptote is going to be y equals 3. So I can think about kind of what's going on here. I got a horizontal shift. It's the minus 1, so right 1. And then I'm going to go a vertical shift up 3. All right. So now if we look at this, if I just did 0 and 1 for my x's, if I plug it into my parent function, 2 to the 0 power, anything to the 0 power is 1. 2 to the first power is 2. And then I got my transformation. So I'm going to go right 1. And then I'm going to go up 3. So that gives me my 2 points. I got 1, 4 now, and I have 2, 5. So if I take that information, I come over here and sketch it. My asymptote up here was y equals 3, so I got a horizontal asymptote. My 2 points I'm going to plot now are 1, 4, so over 1, up 4, and over 2, up 5. And you can kind of see its growth, so it's going to go up like this. And you got your sketch. It's pretty straightforward. Domain, how far left does it go? Negative infinity. How far right does it go? Positive infinity. It's always going to be that. Now my range, as far down as it goes, it approaches that horizontal asymptote, but the definition of asymptote means it approaches that line but does not cross it. So it gets closer and closer to the negative 3 but doesn't cross it, and then it goes up forever. So in behaviors, x approaches negative infinity. My function's going to approach the horizontal asymptote, which is 3. And then as x approaches positive infinity, my function goes up. So it's going to approach positive infinity. So what we have here, kind of a hint, one end, I want to do one arrow. So one end will always approach the horizontal asymptote, and one end will approach either positive or negative infinity based off of growth or decay. So a lot of the information is still the same. It's just looking at it a different way. All right? If you need to back up, I know I'm going kind of quick through this. Pause it, rewatch it, and you're good to go. All right, let's take a look at a decay problem. So here, my parent function is going to be y equals 1/2 to the x power. 1/2 is between 0 and 1, so that's a decay. Horizontal asymptote is going to be down 1, so y equals -1. So your two things here, you got a horizontal shift, we're going to go left 2. We got a vertical shift, we're going down 1. So my basic xy, so I got 0 and 1 for my x's, so if I plug them in, 1/2 to the 0 power, anything to the 0 power is 1. 1/2 to the first power is 1/2. Now I'm going to go left 2, and I'm going to go down 1. So my point values here, I got -2, 0, and then I have -1. 1/2 minus 1 is -1/2. Cool? All right, graphing this, my asymptote y equals -1, and then I have my points. So I got -2, 0 is here, -1, -1/2 is here, and all I'm looking for is a sketch. So it's decay, so it's going to go down to the right, so it's decay. You got your domain and range now, so how far left, how far right, so negative infinity or positive infinity, or remember you can do all real numbers. My range, how far down does it go to the horizontal asymptote, so it's -1, how far up, forever. And then your in behavior as x approaches negative infinity, so my left side it's going up. So, and then as x approaches positive infinity to the right side, that's getting closer to my horizontal asymptote. So we end up getting -1 here. All right? So some quick sketches, we're good to go. All right? If you want to pause it and go through these on your own, you're more than welcome to. I'm going to go through a couple. If you want to pause it and then try it and then play it afterwards, you're more than welcome to do that as well. So another one here, parent function. My basic is the 1/3, that's what's in parentheses. So 1/3 is less than 1, so that's a decay. Horizontal asymptote is 0. I'm not adding or subtracting anything. So here I got a couple different things. I'm going to go left 2, and I got a vertical stretch by 3. All right, so let's look at our t-chart. So 0, 1, when I plug 0 in, 1/3 to the first power is 0. 1/3 to the first, sorry. You know what I'm saying. Anything to 0 power is 1. I completely messed that up. Anything to 0 power is 1. 1/3 to the first power is 1/3. So now I'm going to go left 2, so I'm going to subtract 2. Remember your vertical stretch is a multiplying. And then let's simplify. So here, I got -2 and I got 3. I got -1 and I got 1. And now we got enough information to graph it. So y equals 0. I got my asymptote here. I got negative 2, 3, and I got negative 1, 1, and you see how it's stretched. And we're good to go. Cool. And then fill in all my information here. Domain is always negative infinity to positive infinity. How far down? 0. How far up? Positive infinity. And then here we go. As x approaches negative infinity, my graph goes up. As x approaches positive infinity, so the right side, it approaches 0. All right. All right, we got a lot on this one here. So parent function y equals 2 to the x power, which is growth. Horizontal asymptote is 5. So I got a lot of information here. I got right 3, I got up 5, and I got a vertical stretch by 4, and then I got a reflection. So reflect over the x-axis. So a lot of stuff I'm gonna have to do here. I'm probably gonna run out of space. So 0, 1, so 1 and 2. I'm gonna plug it into my parent function. Now I'm going right 3, so I'm gonna add 3. Remember here, I'm gonna multiply by the negative 4 because it's a stretch and a reflection, and then I'm gonna add 5. So that gives me my points. I got 3. 1 times negative 4 is negative 4 plus 1 is 1, so I got 3, 1. And then I have 4. 2 times negative 4 is negative 8, plus 5 is negative 3. So I got my 2 points. I'm good to go. So let's slide this over. This is going to be pretty good. So I got my asymptote. I got 3, 1. And then I got 4, negative 3. So you see how these are kind of over here. So I'm going to get closer and closer and closer. And it's just a sketch. You could add more x values if you wanted to. But we're good to go there. So now my domain, how far left, how far right, all real numbers. Range, how far down, it's a decay, so the negative will come first. How far up, it approaching the asymptotes as well. All right, in behavior, so as x approaches negative infinity, my graph's getting closer to the axis, or sorry, my asymptote, so 5. And as x goes to the right, positive infinity, my function's going down. And we're good to go. All right, finishing this up. What is the letter E? So in math, the letter E is just a number. It's kind of like pi or I. It's irrational, so it's that really, really, really long number. So remember, pi was about 3.14. I is just an irrational number. E is about 2.72 if we're going to round it. So we use E when we're talking about specific growths or decays. So we're going to do the same thing kind of here. So the last two have E in it. E is always going to be exponential. So our parent function is going to be y equals e to the x. E is about 2.72, so it's growth. My horizontal asymptote here is y equals 1. All right, transformations, the only thing that it's doing is it's going up 1. So what we have here, 0, 1. So e to the 0 power is still 1. E to the first power is 2.72. And we're going to take this and we're just going to translate it up 1. So I have 0, 2, and I have 1 and 3.72. And you got your 2 points, so you're good. It's nothing really to freak out about. Boom here. 0, 2, 1, about 3.72 you're going to be estimating. So you got your graph. Growth, it goes up. So domain here is all real numbers. Range here, how far down? It goes to 1. How far up? Forever. As x approaches negative infinity, so the left side, it gets closer to the asymptote. And as x approaches positive infinity, so what's happening on the right side? It's going up. So positive infinity. All right, and then the last one, a decay with it. So y equals e to the x. It's decay. Sorry, I'm losing my mind. It is still growth because e is 2.72. And we're going to go up 2. So I got a bunch of different things here. I got a left 3. I got an up 2. Vertical stretch of 2. And a reflect. So a lot going on here. So 0 and 1. 1 and 2.72. So remember, what I'm going to do here is I'm going to go left 3. I'm going to bring these points down in a second. So I'm going to multiply this by the negative 2 out front, and then I'm going to add 2 as well. So what happens here, I'm going to bring these down here so that way I have room. So I got negative 3. 1 times negative 2 is negative 2 plus 2, you get 0. So negative 3 is 0 is going to be on my graph. 1 minus 3 is negative 2. 2.72 times negative 2 gives me a negative 5.4 plus 2, so I got a negative 3.4. And I got my points to graph. So y equals 2. This one's a reflection, so it's going to go down this time. So negative 3, 0, negative 2, negative 3.4-ish. And we're good to go. You can always type it in the calculator if you need help, or Desmos, you can get a sketch so it looks the same. So all real numbers, range, it goes down forever and then up to 2. And then as x approaches negative infinity, my graph's getting closer and closer to the asymptote. And then as x approaches positive infinity, so it goes to the right, it's going down. All right. I know it was quick. I know it's a lot of examples. You can pause, you can ask questions, you can go back through it. But this is a lot of information on graphing exponents. A lot of the information is still the same. The charts are still the same. You should be able to do all the characteristics now. I did not break this up into multiple days since we did that with the last unit. And all the information is still the same. So now it's just taking this new parent function and applying it with all your transformations. All right? Got any questions, let me know. Other than that, hope you have a wonderful day, and I will talk to you soon.